Hello.
Hello. Yes, ma'am. Should I start?
Yes, sir. Yeah, it's 9:35. So I guess we can start. There are total 143 attendees joined with us. So
Yep.
gradually they will be joining us.
Yes, ma'am. Okay. Are you able to see two terminal screen, ma'am?
Yeah, absolutely. Very clear.
Perfect. Thank you.
Thank you.
Okay. Hello, everyone. Good morning. So, okay. Yeah. So today's agenda is to carry forward yesterday's work we did on the implementation flow from using the OpenLane platform. So what we are going to do is first, today we are going to target the power planning aspects, and then we'll gradually move along into the floor planning aspects as well, and then see how far along we can go. Um, the floor planning and power planning, they're all done in the same step of floor planning in the OpenLane framework. So it would means we'll be changing options in the same file. So let's start exploring that a little bit, and let's start from there. Give me just one moment. So what I would ask everyone to do is open their directories where they have installed OpenLane framework, and then we'll proceed from there. So we're going to take it slow so that everyone is able to do. There will be a lot of stuff for you guys to do. Okay, so we want to go to RTL2GDS, OpenLane. So this is where we want to go, and then what we want to do is, as discussed in yesterday's lecture, export PDK root to where you have put your libraries. So for us, it was the folder where we installed Open or did a git clone on the OpenLane. Now what we'll do is we'll run the Docker, and now comes the interesting part. Okay, so till now, what we had done yesterday was we opened the Docker and we did a init design config on serve. So let me open the file. So I'll open it in another repository which we created yesterday. So for just for the test purpose, what we did was we did test OpenLane. Let's go to OpenLane. Let's go to designs. We created a server repo, right? So till yesterday, we created this. We created a config file using which command? So wait, before that, what we did was we took the source files from the RTL directory of the serve, which was given to you in the drive. We took all those RTL files and we pasted, copy and pasted them in the serve design serve src directory. We created this directory ourselves and we pasted them here. Then we ran a command / flow design serve init design config. And then this config file got created. After this config file got created, this is where you will be all changing everything you will be working on. This plus config, you can also change the global configuration files. We'll test it both ways. But for your reference, then what we did was we changed the name of this to the top module which we have. So for us, the top module is serve top. So we changed that name. We made sure the clock name matches the clock port name over here. And currently we are running the flow for 10 nanosecond period. We'll also try to run a regression later on for smaller and bigger periods and see how that affects our design. Okay. So that's where we are. Anyone has any questions into the refresher of yesterday's work? Otherwise, we can proceed forward. Please feel free to ask if you do not understand what we have done till now. Okay, so I would proceed. One thing I would like to just say in general, not pertaining to this course, is I've noticed that most of the time participants are quite interested in just attendance, marks, and stuff like that. If you actually are just interested in that and just a certificate, you're actually not really using the such courses to their full potential. So just try to have a better perspective of why you are doing what you're doing, just pointing that out in general. So let's proceed. Okay, so where we are right now is, let's open now the configuration files. Okay, so what we want to do is today we'll be playing around. Today we'll be playing around with the configuration file in the floor plan. Okay, in the floor plan, and there itself we'll added the power plan. So let's go to our directory E&ICT RTL2GDS. We'll go in the open lane. Here in the configuration file, there is a file called in the configuration folder. Let me show you a path. So open lane configuration. Okay. In the open lane configuration, there is a file called floorplan.tcl. We can do the changes here, or we can do the changes. We can do the changes here, or we can do the changes in the main configuration file which we have. Okay, so let's try to open this file and see what we have. Okay, what we have here is just give me a moment. I need to get a better editor open here. It's taking for some reason with WebEx, it really interferes with it. Let's try again and see if it works. Okay. Guess not. Let's try. Otherwise, I'll just open it in Vim. Okay, I think it's better to just open it in Vim. Okay, let's just open it in Vim. Okay. So what we want to do is we want to change and edit this file. And let's first observe what the file contains. Okay. So the file contains different floor planning aspects. We'll come to what this sizing relative, absolute, core utilization and all that means in a bit. First, let's try to focus on some of the aspects which are over here. We are talking about power distribution network. Okay, this is what we are targeting. So let's try to visualize what power distribution network first means using some slides, and then we'll come back into how do we change things here to be able to do a better power distribution network or a different power distribution network. Better is always with respect to the application. Okay, so let's see. So yesterday we were here, right? We are talking about power distribution network. So how typically power distribution is done is what we have is we have all these pads. Okay, what do we mean by pads? So from the external world, there is a PCB on the outside over here. Let's draw something here. So there is a PCB or where you place this. This is your die. So this is your die. This complete thing. And from the external world, there is usually a PCB. And then this PCB also had something called connections, which actually connect to your actual connection. Then you do gold bonds here like this. You connect wires. This is the most simple form of connection. Okay. Now, what happens is these connections, some of these would be VDD and some of these would be grounds and some of these would be other signals. Let's see one thing. A, U, and A. Okay. Yeah. So some of these would be VDD, some of these would be ground. And then usually in the pad ring, there are this VDD and ground is completely connected in the pad ring as well. From the pad ring, then what typically one of the design strategies is in the higher level metals. So which were the higher level metals for our design? So in SCIF 150, it might be M5. In M5, which is the highest level metal, we draw horizontal or vertical wide lines, wide interconnects or power distribution interconnects. So we draw wide, which connect to the power rails in our pad ring. And these power rails are then connected to our standard cells. We drop vias directly from this power rail into the M1 grid or M2 grid of the standard cell. Everyone understands this, or anyone has any questions on this power distribution strategy, which is this is one of the power distribution strategy. It can be anything based on your requirements and application. But typically your global power is done in higher level metals. And then there are rings of power distribution in your pad ring. Then you create a mesh or rings locally. And then what you do is you are able to then connect to those by dropping vias. Now there can be another situation. Suppose you have a macro. Let's call this a macro. Okay. what you can do is outside the macro, you can also create power ring. This is your macro at the center. These are power rings, and then you connect these power rings to the VDD and ground mesh, or you can connect them to from here. Any way which is best for a power distribution network. So in overall, what your goal is to be able to deliver power with the least IR drop to your either macro or your standard cell. And also, if there is any inductance in the path, you want to minimize ringing by having enough decap. But in general, the global power distribution is with rings and meshes and in higher level metals, and the local power distribution is always in M1 or M2. And you drop peers from this global mesh into the local mesh. If it's a macro, you have rings around the macro of power distribution, and then you connect those rings to your global power mesh or ring. So blue part was just, I was trying to point, it can be anything here. Let's just, because it's not clear, it's a good point. What does the blue part indicate? Let's try to go back in again. Okay, so this, I was actually trying to show that these are metal connection pads, and then they are going into a lower level metal, which is going into circulating in the pad itself in a couple of layers. It can be one layer of VDD, one layer of ground, or there can be parallel VDD and ground circulating here. And then in the lower level metal itself, there is a VDD and ground buses which get connected from that, depending on how many metal layers you have. Sure, means it can depend on how many metal layers you have. And in general, you try to do as much, you try to grid, or you try to create a very extensive low loss network in the higher level metals. Okay, so this is what we want to do, basically. This is what we would like to achieve in our today's session of basically power distribution network. Now, currently, I don't want you guys to edit your configuration file at all. Okay. What we want to do is we want to now boot up our design. That is our goal. We want to boot up our design. So what we'll do is we'll run the command against flow.tickle. We'll say design. Then I would advise you to use something called tag. Before tag, let's put the design name, which is the folder name. Okay. Before that, rule is asking good question. What are the rings around the macro? So basically, when people create macros, they want to create a good power distribution strategy within the macro for itself. So create the power distribution in the macro, and then they provide rings around it, so that when we do external routing to that, we only have to connect it to the rings. It's just for the ease of nice power distribution from whoever is designing a macro, because the macro might come from another team, another company, someone else. Okay, they do their own power distribution basically. Okay, so the design serve, and then what we'll do is we want to do tag, I would advise you to just do something, put a name. It will be easy to for you to identify the folder. Otherwise, it gets it gets very hard because it puts the dates and the time tag. Then I would advise you to also type overwrite. So every time you'll be overwriting this test EICT folder rather than creating a new one and creating huge memory usage in your PC. So use flow.tickle, your design is served. The tag is the design folder you're creating for all your repository work. For everything you'll do, everything will go there. And you're saying overwrite to make sure that everything gets overwritten and you don't end up creating hundreds of folders. Then do something called, use a tag called interactive. Interactive, okay? This is what I advise you to do. If you do this, then something like this should open up. I would wait for everyone to try to do this. For everyone's reference, this is the command I ran, and then it will be able to do this. I'll wait for 2 minutes to everyone to catch up here. Okay. And in the meantime, Vishnuvardhan is asking why only 5 metals, why not more? Because every mask is money. The more metals you put, the more expensive the process gets. That's why only 5 metals. Plus in 130 nanometer, the feature size is still big. So you can do robust power distribution in just M5 itself, and local and even some of the global interconnects might work in M2, M3 itself because they are quite thick. I'll wait everyone to run this command and catch up and reach this stage, and then we'll start playing around in this interactive open lane environment. Okay, questions. Rajesh is asking, yes, this is the command Rajesh I've run. /flow.tickle with design serve. Serve is the folder name of the design we created, not the top module name, but the folder name where it resides. Tag is the new folder which will be created in your run directory. We'll go and look at that. But just so that your OpenLane doesn't create hundreds of folders for you, you can always go back to this folder. Then overwrite is to make sure you overwrite in this folder always, otherwise it will error out. And then interactive is to open it in interactive mode like we have right now. So try to run this command. Then there is a question which is asking what is the material used for interconnects. Depends. It used to be aluminum, copper are usually the interconnects, and width is it was all shown in the layer stack. So you can, it was a little around a micron or something. Go back to the layer stack, which we discussed in yesterday's lecture at Patna. Okay, I'll wait another minute for everyone to catch up here and have this interactive environment loaded up, and then we'll go forward. So basically this command takes you to Docker, then you run the Docker, this command. Okay, then we are asking, yes, Pradyum is asking, should we use high level metal for proc distribution also? Yes, we'll look at that in the CTS lecture we'll have. How do we, what is the general strategy for optimizing metal layers for CTS basically? We'll look into that a little bit. But generally any global signal, high level metal, or global signal, middle level metals, local signals M1, M2, power distribution, top level metals. Okay. So now here what we want to do is, it's some of these commands are actually quite simple. We just want to run the flow. It's quite straightforward, but for now what we'll do is we will actually try to run it in stages and understand. So synthesis we have already done in USS extensively. So this we'll just do this. Just type run underscore synthesis. Okay, and your synthesis should run. So the command I typed was run underscore synthesis, and your synthesis should run. I repeat, the command was run underscore synthesis, and all this should run. We type the command here again. Do not rerun the command. I'm just typing it here for your reference. So run the command run underscore synthesis like shown here. Run this command. Aparna, in this environment, yes, you can have two voltages, but you have to make sure that you do your power distribution yourself. And it depends on how do you set the power distribution strategy. So we'll look at that a little bit in the next few in the next hour or so, how the power distribution is done, and then you have to create your own power distribution, own pad ring for two voltages, and then you can have two voltages. Okay. So the command we want to run is run synthesis, and your environment is set up correctly. You should be able to run the synthesis on your design. Okay. I'll wait for another 2-3 minutes for people to catch up and try to run the run synthesis command at their end. Please check uses file. So there will be definitely some errors which are looking like this, cannot open something. Do not worry about these. Apart from that, your overall synthesis should run. Okay, so seems people have some issues with respect to their environment. What we'll do is we will I'll try to keep explaining you what is happening, what is happening, and then in the background we can try to catch up and try to see why your processes are failing. Okay. Now, means this is expected because it's the first time you're running this in your environment. It takes a while. So let's try to visualize what happened when we ran the run synthesis command. When we ran the run synthesis command, what happened was in the serve directory which you created, there would be a run directory there would be a directory called runs. This is the directory which should have gotten created. In this directory, what is the name we gave? We gave in our, if you remember in the beginning, when we actually loaded the design here, we said I gave the name test EICT. In the beginning, I gave the name test EICT tag. So test EICT, that's in this directory. There should have been all these files which got created. Currently, the results reside in two directories. One is results, and here currently we ran synthesis. So after running synthesis, there should be a file called serve top synthesis.v already present. This is the post synthesis output. Now, for anyone who is having errors, there must be logs of error. You can go back and refer in the logs. What is failing, what installation or some environment variable is not set correctly at your end. The one point to note is you have to remember to run the commands as we are telling you. If you miss anything, if you do not set some PDK root or anything correctly or a permission correctly, every time you load your terminal, this will not run correctly. This is true for any tool in general. You have to load your environment correctly. So anything, if a temporary process is running, your results are stored in the temp directory here. This is where we look and how the temp results get placed over here. This is where we'll be looking the next few steps. So I think, okay, Shreyash is asking a question. It is taking me, because Shreyash, you did not do init design config. As I mentioned, if you do not follow yesterday's work, it will not work. You have not created a config file at your end. The first command which we ran yesterday was init design config. So most of these errors are because you guys have not completed previous work step by step correctly. Okay, redefinition of module serve ALU. That should not occur because we gave there. You must again, there was some error in the loading of the serve files. If you make sure you have copied the files from the one we gave. So Ruel, I would advise you to go and look at the log file in this directory, as I mentioned here, and see what is the error. So the next step after doing the run synthesis command is, so all of the people who are getting Docker permission error, I have told you, you have to run the chmod command. Again, please please try to run the commands correctly every time, otherwise this will not work. The init command exists but is reading somewhere else, then you must not have set some path correctly. Or your libraries have not been created correctly, Shreyash. Init floor plan is the next command we want to run. The next command we want to run is init floor plan. We'll look at what different floor plan options are. And but this is the first command we want to run, init floor plan. So we'll try to figure out in a bit how this values come from, area, height, and all that. But at the end of this, it is showing that layout is saved in my runs folder, which was created, test EICT temp floor plan. This is the new file which got created. So let's go and look what happened. Okay, we'll look at how do we change this in a bit, but let's look at what happened. So in the temp directory, I want to go into the floor plan directory, and I want to open a layout over here. And this is the file which was created, this def file. And as you can look, this is just a rectangle. There is nothing more over here. So made any other branch is fine for the work. There might be some changes we'll have to do in the runtime. So this is currently only when you do init floor plan, a rectangle gets created with the outline of the, this is on the outline layer. This only has the dimensions of the block you're trying to create. Okay. Now let's go back and run a few more commands. Currently, I would advise you to, okay, let's do EDN gen. So the next, let's wait for 2 minutes and then let everyone be able to first run init floor plan, go into their temp floor plan, and observe if there is a file called Verilog to def open road def which got created, and that try to open it using klayout. So in the meantime, let's look at somewhat what you have to figure out what the error log file is saying. Just the fact that there is a file doesn't solve anything. Okay, so what I'm observing generally is most of the errors are because someone forgot to specify PDK root, or someone did not run the chmod command for their Docker if that was not set correctly, or someone forgot to run the open lane in the correct folder. These are generic errors. You have to make sure that you run them correctly every time. If you don't do that, then the process doesn't boot up correctly. Okay, let's wait for 3-4 minutes for everyone to catch up, do an init floor plan, observe that you get this basically in your temp directory. Jagdish, if you did a git clone of RC6, then it should be able to find RC6. Otherwise, as Sumedh is pointing out, you can actually do a GitHub installation of any branch, whichever branch works for you in OpenLane. Go ahead with any other branch, it's fine. You can clone anything, whichever is booting up. There are other GitHub links to the OpenLane environment as well. Whichever boots up correctly in your environment, that is fine.
Hello.
Sorry, ma'am, I was muted. My bad. I forgot. Got it. Sorry, ma'am.
Okay.
Yeah,
Thank you.
sorry, I'll repeat. For everyone, please do a gen_pdn command at your end. Do a gen_pdn command at your end after your init floor plan. And in your temp directory, now there should be a file called pdn.def. If you open it with klayout, you should see something like this. It will not be exactly same as this because I've changed my power distribution strategy. We will now, I will wait here for 5 minutes and everyone to catch up here. Then we'll try to understand what this power distribution strategy is. How can you change the strategy to other strategies? What are the different ways you can do it and stuff like that. So I'll wait for 5-10 minutes here just for everyone to do a gen PD and catch up, open this in klayout in the temp directory. Okay, let's wait and everyone to catch up over here. I'll wait another 2-3 minutes and then I'll try to explain how do you analyze the power distribution network here in a bit. Okay, so Rajesh, you can figure out if your rest of the commands are running successfully, you can figure out the error later on. Please make sure you guys copied the modules we gave. Okay, yes, you're getting the EOSIS errors, so you'll try to run the thing separately in EOSIS and try to see if you still get those errors. Okay, because we've already shown you how to run things in EOSIS, I would advise you guys to run after this session separately in EOSIS and see if you still get those errors and then try to debug and then try to catch up here. Okay, what I want to show here is I would like to show you how do you analyze a power distribution network? Suppose whatever is loading up at your end also, right? How do you analyze that? So let's try to get rid of layers. Obviously, these layers do not exist because these are NVEL, PVEL layers. This is power distribution network or metal distribution. So none of this should be active. And as we are seeing, if I turn these off, none of these matter. So what mattered was this. See, there is this M1. Let's start from the start changing this. My bad, I'm sorry. This is okay. Let's try to get rid of this. Let's try to turn these off and then we'll try to understand what's going on. Okay. So labels and pins, don't worry about it. Let's start with the M1. So currently the power distribution network which I've created, let's see what that is. And then do the same thing at your end. See what is the one you are getting. Okay, then we'll try to see how do you reach from the one I have to the one from the one you have. How do you reach to the one I have? So what do you have? You have M1 grids. sorry, M1, these are your standard cell placement grids. So a standard cell will fit between these two, these two, these two, and so on. So you have your M1 power distribution over here. And then if you see, there is the first via. This is where the via stacks will drop. You can select them and press Q, and it will tell you the properties, what layer this is on, what via this is called, whatever polygon properties are. Then if we go up, let's see if we have metal 2. Yes, because if these are via stacks, these should be coming from the higher level metals. So there is a via stack going up. Similarly, now if I do metal 3, yes, obviously if it is coming from high level metals, again the metal stack is going up. Let's see what is an M4. So how this distribution is done is there is vertical M4s. Okay, let me get rid of M1 here. If I get rid of M1, what we have is our M4 was our high level metal. So there is a vertical M4, which is going all across your die area. This vertical M4 is dropping the vias directly on top of your horizontal M1 standard cell grids. Okay, so this is what we have. Now let's get rid of this one and see how the high level metal distribution has been done. Okay, let's delete this, sorry, not show this. Let's get rid of all this. Let's just keep M4 for now. Let's see what happens with the M4, M5 thing. Okay. If I switch on M5 again, now what do we observe? We observe that there is a M5 horizontal and an M4 vertical, and then there are these vias. At every alternate one of these, there are vias dropping from M4 to M5. So a via over here, a via over is a via which is getting dropped. Okay, so basically you're creating a Wheatley VSS mesh in M4, M5 with a given thickness and width, pitch, and so on. So we'll try to see how do we change such parameters. Okay, so I hope everyone understands how power distribution networks are created. If after this, does anyone has any doubt in this visualization of a power distribution network? And not everyone is able to boot up the tool environment correctly, I understand, but your concepts should be clear because booting tool environments takes a while. Not everyone is used to Linux environment, not everyone is used to tools environments. It takes a while. So it will take a while for everyone to catch up. And it takes a while for everyone to catch up and fix these Linux based errors. But in parallel, as we are discussing these concepts, please do ask me if anyone has any doubts over here with respect to this power distribution. Does anyone everyone understand what is going on here? What did we do? Any doubts from anyone? Good question. Let's get rid of our M1, M2, M3 in parallel. So I got rid of M4, M5. Now let's look at M1, M2, M3. So M1, we have horizontal for sure. Okay. So we have a horizontal M1. Now this horizontal M1 only needs to connect to the power grid in M4 and M5. So you have M1, M2, M3 in parallel only where there are vias. So if there is a via over here, we have M1, M2, M3 in parallel only at that location where there is a via stack. Now, let me just show you here. See this M2, M3. Now, can someone tell me what will go wrong if there was M1, M2, M3 parallel in all of this? Everywhere there is M1, if there was M1, M2, M3 in parallel. What might go wrong? Can someone tell me? Okay, so starting with short, what will short? Rajesh is saying high capacitance. So high capacitance is actually good. It will be higher capacitance and lower resistance, which is actually good. So why don't we do it? Why don't we create M1, M2, M3 in parallel here? No, actually, crosstalk, you will actually have a more robust power distribution, right? If you're distributing power in all layers, you're distributing power in M5 and M4, and then M1, M2, M3 at the bottom, you will actually have a lesser resistance and higher capacitance. And higher capacitance is actually better for your power distribution networks. So why do you think people don't do it? Why not have M1, M2, M3 in parallel over here? So Surya Krishna is in the right direction, layer shorting. Naveen will come back to your for sure. We'll come back to how these spacings work. Don't worry about it. That is the agenda for today. Yeah. So I think I might not be pronouncing the name correctly, but Uma Bhargavi is uh, is absolutely right. If you have metal layers M1, M2, M3 in horizontal and M4, M5 mesh on top, where will you route your signals, right? There is no signal routing left. So you have to make sure that the power distribution you do, you still leave enough layers and enough routes for your basically the rest of the signal routing. Yes, absolutely. Now everyone is in the right direction. Good. So have to leave enough spacing. So right now you have enough spaces here. You can have vertical and horizontal routing in M2 and M3. Right. If you do not leave that, then you see you will not be able to do routing at all. You will not cannot do signal routing. So that is a trade-off most of the time we have to deal with. How much power distribution network to put and how much space to leave, how many VR taps to, how many, basically how many VRs to drop from the top level metals to the bottom level metals, because every VR you drop is going to obstruct a signal routing layer. So there is a fine line trade-off between the signal routing and the number of years which you can drop. Okay, Surya Krishna is asking why alternate years from one another. So the reason for alternate, it's a good question. So the reason for alternate is, let's start, it's better to understand. Okay, let's start from the bottom. Okay, so the topmost layer, let's assume this is VDD. Okay, then if you connect it to a standard cell, this one would be VSS. Then this one would be VDD, then this one would be VSS. So every alternate layer is connected to VDD, this, and that's why every alternate layer is connected through a VR to a top level metal. Basically, you create a mesh using every alternate layer. That's why every alternate layer is connected to one another, because one of them is VDD, one of them is VSS. Is that clear, Surya Krishna? Okay, perfect. Good questions from everyone. And I think everyone is able to understand this power distribution network concept. Very nice. Okay, so this is the power distribution network we have. Now let's try to start changing things a little bit and see, okay? What I want everyone to do is I want everyone to go into the folder. Let me open another terminal. Okay. I want everyone to go into OpenLane configuration folder, and I want people to do this. I want to open floorplan.tickle in Vim or any other text editor of your choice. And then what we'll do is we'll try to change these parameters. Okay, let's try to make change these parameters and see what it does. So you have 4 parameters over here. Basically horizontal pitch, horizontal offset, vertical pitch, vertical offset. I want, okay, can someone take a guess? Let me open the def over here and let's try to guess what would horizontal pitch mean and what would vertical pitch mean. So we have these 4 parameters over here. What do these correspond to? PDN, vertical offset, vertical pitch, horizontal offset, horizontal pitch. Sorry, my bad. Yes, absolutely. So basically the pitch is your vertical layers. What is the distance between them? So what is your vertical layer? The vertical layer was M4. It all M4. Let's come on. Yeah. So what is the vertical pitch of this? The distance between the two. And what is the offset? Offset means from the, if you look at from the outline, how far away from the outline, how do you set that? That is one of the things. There is another aspect of this offset and pitch. Let's try to understand that a little bit also. Pitch is okay. I want to go here. There is another file I want everyone to know that where is now. There was a question from one of the students that where is this PDN generation being done? How is this being set? Okay, so there is a folder called scripts, right? We visualize this folder before, so we will try to go in that folder to see how this PDN generation is actually occurring. So if you go in this folder called scripts, there is a file called genpdn here somewhere. There should be, let me check. Not this. Basically, where did that go? Not over here. Let me try to locate that file. There is, oh yeah, sorry. Let's see, it's in the PD engine. Okay, let me try to locate that file. In the meantime, what I want to go is, I want to go in the designs and I want to go to the directory we have created, the serve directory. And here I want to show that if you want to change any of these parameters now, you can actually go ahead and change them over here in this user config. So any parameter which you will change over here will take precedence over any other parameter you have set. So for example, there were these parameters in your floor plan configuration file of vertical offset, horizontal offset, vertical pitch, horizontal pitch. If you redefine those parameters here in your configuration file of your own design, then they take precedence over any other thing. Okay, so you can redefine those and they take precedence. Okay, in the meantime, there are questions. Prabhavati is asking, yes, pitch is measured from center of a layer to a center of the same layer. Center to center distance is pitch. Yes. Let's see. And now I want to go into here and I want to do give me 1 second. I want to show you a presentation. Okay, so this is was our current currently what we had was this was your current environment. Now I'll try to explain from here what different things here mean. So we already look at these different values, offset pitch for different layers. We'll also go how do we individually define some of the other layers. We'll go and do that. Because if you define them globally, they supersede what you have defined already. Now, there is a core ring option. When you have a core ring as one, what that does is it puts a ring around your PDN. We'll go and try that. Enable rails, it actually, the rails which you have created for VDD VSS, if you don't do this, it will not create those. Auto adjust is for you to be make some features of a PDN generation automatic. So this is set in your floor plan .tickle. Then there is another aspect of it which is in a configuration file for PDN. So this is what we want to observe. Where does this exist and where do we want to put this? Okay, so we'll try to change this. How do we play around with the PDN network? For sure, Surya Krishna, you can do anything with the number of rings, any number of rings, and so on. Okay, let's try to see. We want the okay, there is there should be something called GenPDN here. Nope. Or PDN. I'm trying to find the repository for PDN. There is open road. In the open road, there is one. Okay, let me try to locate that. Don't know why I'm missing that. in my repository, place diodes, gen PDN. Okay, give me just a moment, I'll locate that. Yeah, I advise you to everyone to try to change. Yeah, in the meantime, what you should do is try. I am trying to do some other changes in the PDN script. What I would advise you to do is test this flow, this vertical offset, horizontal offset at your end, and see how it affects. So one of the issues with the open lane is that what it does is you are not able to basically do an active change. So you'll need to exit from your environment and run this interactive environment again. So this will let you practice things a little bit as well. Before you do that, you should go in your configuration directory, open this floor plan.tcl, change these values, change all these values, and see how it is affecting your design. Okay, I want everyone to change these values, these PDN values, and see how it is affecting your PDN generation. Every time you do that, please exit and create a new repository again. And okay, this location is pointing out to the PDN one. Okay, this is fine. So every time you do that, exit, and for example, what we can do is we want to be able to let's change something here. Let's make this, we can make this 26. I can do WQ, and then we have saved this, and then we go back here, we run this in interactive mode, and then we do run synthesis. And after that, we do init floor plan, and then we do PDN, sorry, gen PDN. This way, you will have another PDN in your repository, and you would want to go and observe what that is. So try changing these vertical offsets, horizontal offsets, vertical pitches, horizontal pitches, the IO ring option, and all that, and see how that affects your design. Always exit, always create, observe it, then rerun your open lane environment. Do that, and that would answer your questions. Okay, Lakshmi, as I pointed out, you cannot do giant PDN just after changing the script. You have to exit and rerun the whole thing again from run synthesis to init floor plan to PDN gen. If you do not do that again, then it will not work. It will exit abnormally. So that is your task for next 10 minutes. Basically, you will be changing the offsets, the pitches, and trying to rerun the code. Init floor plan, sorry, run synthesis, init floor plan, PD and gen. These are the three commands. Run them after changing all these values to different values and try to see if you're able to observe changes in your overall layout. Yeah, please do that. If you're getting errors during synthesis, I've already shown you how to run Yosys separately. I would advise you to run Yosys on the design and see if you still get the error. Okay, so again, pointing out what do you guys have to do? You have to change the pitch, you have to change the offset, you have to change, I'll put the slide deck up, change these options basically, and try to observe if you are able to rerun the floor plan, run synthesis, init floor plan, and then do PD and gen. Observe the power distribution network again and see what are the changes. So first of all, if someone can tell me if they do this core ring to 1 or 0, what is the change? I would like the answer to that in the Q&A session. So anyone able to run? What is the difference? There's no point in moving forward till people try to catch up now, because we'll be extensively changing a lot of things. If people have not caught up, there is no point in moving forward. So what are now the differences between the in your EOSIS environment and your now go to the EOSIS, synthesis.tcl in your configuration file and try to change things and see what are the differences, and also in your EOSIS log, why is it failing? So in the meantime, for anyone who has caught up, again, I would advise you, please try to catch up. I've seen people have not been doing anything by themselves, so they have been really lagging behind. I would advise you to try to catch up. For all the people who have caught up, let's try to do one more thing today before we call it a day. Let's see. Okay. So I think people are able to figure out the open lane issues with respect to synthesis. That's good. So what we want to do is we want to go in the directory where you specify the export PDK, there should be a path called Sky130A. We want to go there. In this directory, so make sure this is not the directory we gave you, but this is the directory made by make PDK. Okay. In this directory, we want to go to libs.tech and then open lane. And now here there is a file called common PDN and config.tcl. Okay. So we want to observe what is in the common PDN. Again, I repeat, where are we? Your directory where you did a git clone of OpenPDN and specified it as the PDK root. There should be a library which got built using make PDK called Sky130. Inside that, go to libs.tech. Inside that, go to open lane. There, I'm pointing out the path here again. There is a file called common PDN. Okay, so there was a question of how is all these paths, how is the width and everything getting set by default. So this is where everything gets set by default. Okay, so this is where the whole PDN generation is occurring. And let's try to see and go in edit mode what is here. There is different supply net definitions here. There is different width, offsets, all those parameters you pass, they come over here and they're added over here basically. So in my basically design, what I had done was I had added this extra line to my PDN gen. if for anyone who has been able to catch up, this is the line you want to put in this file over here. So this is what we have put. It's in the slides. You can go back and do it at your own side as well. But in the meantime, this is what we want to put over here. I want everyone to type it one by one. Where do we want to type it? I'll give you the path. Basically, you are supposed to type it in. Let me open a terminal and give you the path. Exit this. We want to go to Sky 130A. Then we want to go to libs.tech. And we want to go to OpenLane. Then we want to go to commonpdn.tcl. So this is the file which we are editing. This is the file we are editing. At the end of the file, there is something called, you must have a PDN gen which looks like this. I want everyone to comment that out and type this instead. So comment out, specify grid standard cell, dollar standard cell, and type this instead. So let's try to do this. This will take everyone like 10 minutes at least. Everyone should try to catch up here. Okay. So Surya Krishna, similar to Royal, you must have done something in your .v files. That's why it's not able to run. Make sure and also for Surya Krishna and Venkat, you do not have to do the fuse sock. We already gave you the serve files. So the serve folder RTL was provided to you in the drive. Use that. If it is giving you issues, go copy that again, go download that again from there. There must have been something changed in the files at your end. That's why it's giving you issues. For everyone else who has been able to catch up, go to this directory. There is a pdn underscore common underscore pdn.tcl. Change that to this. There is a command pdn specify grid standard cell, dollar standard cell. You please change it to this. We're specifying a new strategy now. So what's the Lakshmi, please make sure that you are in the correct location. It is Sky 130A libs tech open lane, not your open lane lib. This is I'll give you the path. Wherever you installed your open lane, don't go inside the open lane, because wherever you gave the PDK root, right? In the PDK root, there must be a Sky 130A which got created. If it did not get created, then there is some issue. Try to figure out why your make PDK did not work. Inside that Sky 130A, this is where you are. Not inside the open lane, previous open lane folder. This is a different open lane folder. Yes, use the standard cell one. At the bottom of the file, there is a one called standard cell. Do the PDN gen on that because you're doing the right now. You only have standard cells in your design. Pradam, yes. K layout would be nice to have just to observe outputs. Venkat, you don't need FuseSock. We already gave you the surf files. Use the surf files which we gave you. They were posted in the drive. Okay, so when this will take people some time, that's why I'm giving time here towards the end of this first session. Once you're able to type this in the standard cell strategy, you are supposed to rerun the whole PDN gen again. So exit your open lane, run it again using .flow.tickle, do run synthesis, do init floor plan, and then do PDN gen. And you'll see that your PDN generation strategy has changed. So that is your target for today, basically, observing a new strategy and then figuring out, because I've specified here layers and everything already, width and actual numbers, how do you play around with these offsets, pitches, widths, and actually observe the changes in your own flow? How do you observe these strategies? How does this strategy actually work? You need to be able to do this on your own. So yeah, try to change this in common PDN and then try to observe the change after running the open lane again. When I say open lane again, exit it, do the flow.pickle command again completely in the interactive mode, do run synthesis, do init floor plan, then do PDN gen and observe the change. You need to be able to have the new layout with you. Okay, any questions from anyone? So basically, this is the target for today, that you need to be able to do your PDN generation on your own today. And I'll take questions now, and then we'll wait another 10 minutes for the people to catch up to PDN generation. So try to achieve this. If anything is failing, for example, your Verilog files, copy them again. If your flow is failing, try to set that up. It takes a few turns. Basically, you're new to this environment, you're new to Linux. Don't feel that you're not able to run this. It takes a while to get accustomed to such design flow. Okay, Lakshmi, uses error, do the uses 2 steps again. Most probably the easiest way is just copy the Verilog files again. There might be some error in the Verilog file, something might have changed. Just copy them from the drive first again. New strategy, any source or trial. So basically that I would, so how do you write the strategies is it comes with time basically. There are tutorials on how to write PDN strategies. I want you guys to be able to at least take this strategy and play around with it. So for example, change this to metal 3, metal 4, see what happens. Change this width, change this pitches, change these offsets, change the metal 1 width, metal 1 offset. Change all these things and see how your design power distribution network is changing. That is what your goal should be. That take an existing strategy, can you make it work for yourself? Naveen, because you did not specify PDK root, every time you open the terminal, you have to specify PDK root. We have already discussed that the new terminal means new PDK root. And let's see, what is the, you have to specify PDK root. So anyone who is getting error in their Verilog files, just make sure, just get rid of your source files, copy them again from the drive that EICT Academy has shared with you, recopy them and try to run this flow again. There is a PDK root, okay, and I think I answered Surya's question. Okay, yes, keep trying to do this and see. Copy the Verilog files again in the meantime, everyone who is getting the synthesis error. Define the PDK root in the terminal where you are using the design, Naveen. You have to define it in the terminal where you are in the PDK. So you can even define it after you reach the bash. Just for some reason, your bash might not be copying your PDK root, you can define it there itself. Don't worry about the FuseSock library right now, and Lakshmi will look into how we can capture that later on. If it is giving you the error for PDK root, just echo the command PDK, the address. When it gives the error, then it is not able to basically find that. And with respect to the questions about FuseSock, the reason we are slightly deviating from the plan of actually loading from FuseSock is because people were having issues with the Linux environment setup itself. So we thought we'll just give some files rather than go through that step. The tree, basically some of your Ready4Rock files got messed up. So we, rather than making you import a lot of files, we just provided you files, Lakshmi, yes. Okay, let's wait 5 more minutes and let everyone try to catch up, and then we'll call it a session. I think most of the doubts are solved, and whoever is not solved, I think there is the Verilog file issue. I would advise you to just try to copy that files again and do again. There, Naveen means if the path is there, then it has to find the path. What you're saying is not possible. You're somehow setting the variable incorrectly. Okay, it seems okay. So good question. Naveen is asking, can we vary metal lines horizontal and vertical? Yes, you can vary or lines horizontal and vertical. Basically, that is decided from what is the best utilization of your metal resource. You have a given number of metal lines. You need to figure out which one do I route horizontal, which one do I route vertical. They have to alternate for sure to be able to get maximum routing capability. Now, sometimes you have weird aspect ratios if you have very thin designs, so you might need a lot of vertical routing capability. And say if you have odd number of metal lines, so you might want one extra metal line in the vertical direction. So that is basically how you decide based on your available metal resources. I think, Rosa ma'am, I answered most of the questions. It will take people some time to catch up, and I will share these slides right after this session so that everything is written over there as well, and they can try to follow along after this session as well. We are good, and in like 5 minutes, we can start with Puneet's session. I think excellent questions by everyone with respect to power distribution network, and keep going. It takes a while for everyone to catch up on the Linux part of things and the tool part of things. It is quite normal for people to take longer. If you're doing it for the first time, it takes a while to get used to this. I think we're good, ma'am, for today. We'll catch up again, start again tomorrow on this, and then Puneet will take the next session. Puneet, are you there? Hello, can someone confirm me from EICT side if I'm audible?
Yes, sir, you are perfectly audible.
Okay, ma'am. Yes, sure. Puneet will continue the next session in like 5 minutes. We're good for today. On this, I'll share the slides because participants will need to follow along what we discussed today and practice on their own.
Okay, so we will have a 5 minutes of break. So after that, we will start with Puneet sir's lecture. So thank you, Aditya sir, for your excellent delivery in day 6 of the program. So next session will be taken by Mr. Puneet sir. So we request all the participants to have a 5 minutes of break, and we will join by 11:35. Thank you. So Puneet sir, we have given the sharing rights to you.
Yeah, so I'm just
Yeah,
doing
please have a test run before the lecture.
So can you see my slide?
Yeah, we can see your slides.
Great. Thank you.
Thank you.
Hello everyone. Yeah, so but then I was just thinking like, okay, in a background I will check it because just a few people just mentioned they are facing problem in a CMake. So I was just thinking like, okay, uh, I will just check it once. Just give me 1 second. Okay, so looks like maybe you have highlighted this issue over the WhatsApp message, the WhatsApp group which maybe you have maybe. So I have to just check it once because that should not be a case. And unfortunately, I'm not there. I just realized I'm not the part of that WhatsApp group. So maybe I will just check it and I will see like, okay, where exactly you guys are facing problem. But it should be a very straightforward. Can anyone just let me know what exactly the error you are facing, what it is saying? Because it should be very straightforward as such. If anyone can just write it and just let me know what is there. CMake not found. Yes. So CMake not found. I can understand like, okay, CMake not found. So for that you have to install CMake. So something like sudo CMake thing we have to do in that particular way. So like in my case, it's already installed because I installed it there. But in your case, it's not installed there. So Naveen, so if you have uploaded in the WhatsApp group, like I said, somehow I'm not in that WhatsApp group. If you can just paste it here, maybe I will just check it once. Maybe I check it here and just let you know if it is a very straightforward answer. So, okay, one one question, just all of you guys are facing the problem in the CMake or only couple of people? Okay, let me ask the question a different way. How many of you have able to solve the CMake problem? Yeah, so Lokesh, this is basically the version you're talking about. Like, okay, these versions supposed to be there. Yeah. So, like, Tiwari ji didn't face any problem. So, Tiwari, can you just tell me like what different you have done? Maybe you have just entered all those 4 or 5 commands. Okay, see. So it's good like you guys are discussing like you are not able to install or you're facing some problem in installing a CMake, but looks like there are people they are able to solve the problem. So the purpose of the group is the thing like okay, and if you can read it, if you can just figure out like okay, you have done it, why can't you just ask other people, help other people? So, Surya, let's do one thing. Maybe I will check with everyone. Maybe in that particular group. Like now I just joined that particular group. So now I will just check it. What is the problem? And I will just support you after my session today. Okay. So it looks to me the problem is something else, and maybe you guys are not following the step-by-step section given in the GitHub site. Okay. And Naveen, I have to just check what's the problem, your problem basically, especially the problem which you are facing right now. So I will check it and I will let you know. Okay. So for today, let's start this session. So what I will request everyone. Okay, those who install it, I think uh, they just follow a couple of things which I'm going to discuss with you guys today. And just in case uh, if you are not able to install, that's okay. You have recordings. You can follow those recordings tomorrow also, or maybe once your problem is solved. So that's the best part is like you will get everything there. And maybe I will see if I can install it on a fresh system. I can make a video and I can just pass it to you. Like, okay, that may be something I can try on my side. In the meantime, those who were able to solve it, able to install it, please help other people. All of you guys on the WhatsApp, then just do it there. Okay, so you can just tell like, okay, you can do this thing and you can do other thing. Okay, so now let me come back and I will show you like, okay, what all the different things you have to do. So for today session, I'm not going to do a lot of analysis and everything, but I'm just going to show you a couple of reports. I will just tell you like what are those commands and what exactly you have to do it once you will get an access of OpenSTA. So yesterday we yesterday we have discussed about, I think Venkat and all other things. I think now no need to copy paste the error in a Q&A section. We can discuss in a over the WhatsApp. Now I'm part of that particular group. Okay. So and all these things I cannot solve right now because for this I have to just check it where exactly you guys are facing problem. So like me, I didn't face any problem while I was installing. There are few more of you they didn't face any problem while they were installing. So usually what happen in such a tools, uh, if you just blindly follow whatever is written there, it's easy just to install each and everything. But if in between something happen or maybe you just skip any particular step or maybe something is already present in your uh, system or the environment, then uh, these things happen. So if I have to reproduce it, so I don't know whether I can reproduce this particular part or not. So think from uh, in this angle. So there are two ways. Either I have gone through this particular problem, so it's very easy for me just to tell you like, okay, this is the problem, this is the solution. That's the one thing. Or second thing is I have to reproduce this thing. And so in my case, reproducing is very difficult. Third thing, I should be very, very expert in each and everything, like in an IT side, installation and all other things. So frankly speaking, I'm not expert. I'm also like you guys, just following certain commands, certain things. Yes, I have experience, so on the basis of that, I can make certain comments. But uh, if you will just give me the error like swig executable, swig dir, that is missing. So even I have to debug this particular part. So we'll do it. So it's difficult for me to do on the runtime. Like, okay, right now, if I will do it, it's just I think, wastage of everyone's time. So let's uh, come back to the agenda and let's discuss that particular part. So for today, I have two things in my mind, and that's going to help you a lot. One thing is I just want to show you couple of commands. So let me just see if I can do here. Okay, so we were there in the work directory yesterday, and there I have created this RISC-V. Inside this, if you remember, we have invoked STA, and now this is basically the STA part. Now, yesterday, what we did, we invoked a couple of commands. So what I did today, just for our understanding purpose, wait a minute. Yes. Maybe you may be facing some issue just by seeing it. Okay, yeah. So now I'm here. Let me also make it in this way. Okay. Yeah, so what I was saying, like, okay, what I did, I just created separate files. One is sta1.tickle, one is a sta setup hold dot one tickle. So let me just show you. So this is nothing like you cannot create. You can create yourself also. So I'm just showing you like, okay, what all those commands. So yesterday, if you remember, we did read liberty and at the liberty file. Then we did the read verilog, then the verilog file, then the link design, and then this create clock, this particular part, and the report checks. So in place of typing it again and again, what I did, I just copy paste it in a particular file, and I just saved that particular file as a .tickle file. So this is something I did it so that it's going to be easy for me now, because first what I did, first I yesterday we tried individual command one by one. Now I'm creating a tickle file on the basis of that. So here in this particular environment, if you once you will invoke a STA, then what is the next? What you can do? You can directly source this file, okay, and this is our. You can just source it here, and then you can see you can also see the same results. So yesterday also we were getting the same report. Today also we are getting the same report. So the reason I'm just talking about this particular file because see, now it is saving a lot of time. So you already created a file. You're not supposed to remember all those commands and the file name. You're not supposed to write one by one. So that's the purpose of these type of scripts. So this is serve sta1.tickle. This is basically a script file which most of the people in the industry they are using. And now question come why they are using, because they know what is written inside those files and they want to save their time. They don't want to type all those commands one by one. They just want to source it and they want to get the same result. Now, why now that's the main purpose now. But what happened over the period of time, because new engineers are coming, so they even don't know what is written inside those commands. So what I'm going to do as a, if I'm a lead or if I'm a the experienced guy, and if I want you to do the work on that particular file, or if I want you to give me the result, like this type of result. So what I'm going to tell you, in place of teaching you, I'm going to give you this particular file directly. And I will ask you like, okay, just use this file and just source it and you will get the result. So more and more automation I'm going to do, so that I can just escape that particular portion where I have to teach you each and every command and you have to learn each and every command. And that's very easy for you guys. You can learn any point of a time. Sorry, you can run this thing any point of a time and you can skip all the learning. But as a fresher, as a institution, as a research scholar, that's not the thing. So even in the open lane, like Aditya was explaining, like okay, there are the commands and the flow is there, and you just follow that particular flow. And you can see like okay, if he's going to explain you each and every command, then the time which we have, it is going to be very less. And again, this is going to be a tool dependent thing. So today you are using a open lane, then you have to do all these things. Tomorrow if you will go in some other company with some other tool, then you have to maybe remember all those commands. So, but right now, you can focus on the concept also, like okay, how the things are going to be flow. So that's one of the agenda. Like at least you can do everything end to end. But yes, apart from that, the second agenda of this particular workshop is you can make certain changes in the script or the config file, or maybe you can just make your own script. So, and that's the reason I'm focusing on command by command. And Aditya already told you like, okay, how to make changes in the config file, how to a few commands. He's also explaining you like, okay, how to do that particular part. And later on, you can decide as per your design what changes you have to do it. So that's the thing. Someone asked like, okay, what is the content of the tickle? It's just a command. So whatever you're going to write it here, the same command is I'm writing in the tickle file. So like here, one more thing which we are going to discuss, like report checks, CHECKS, and if you will just only report check, then it will give you this result. But there are certain options. Report checks minus help. I think minus help maybe. Or let me just check it. Report checks. Okay. I think I did it last time. It was help report checks. Okay, see. So even I become confused with this particular help report checks. Yeah. So this is the one of the commands. So there are a lot of commands in an open timer, and you can download that particular reference manual from net if you want to do it. But how you're going to check it, like okay, what are the different commands are there? So there is a help, you can just star. If you want to do it, you can just do in that particular way. So it is a help and star. So now you can see there are the list of commands. So if you want to do it in that particular fashion, you can do in that particular fashion also. Like okay, you just do it um, help and star. It will give you all the commands. And out of these commands, then you can use the commands in your analysis. And it's going to be very difficult just to give an idea of each and every commands. But yes, if you want to understand, there are these commands are basically self-explanatory commands, I would say, like all clocks, all input. It is going to give you all the clocks related information, input related information, register, check setup. Now, if you want to do certain setup check, then what is going to be happen? And if you want to report it, then the report checks are there. So here it is like what is the current design, if you want to set the current design in terms of a particular instance you want to delete. So as a industry standard tool, there are a lot of operations we can do there, and all the same operations you can do using these commands also. Everything you can do here. These are basically the sub, I would say, in an industry standard tool, maybe you may have thousands of command, and here it may be hundreds of commands. But yes, these hundreds of commands are good enough for you just to do your experiment. Now let's talk about our important command where we will focus today. That is a help report check. Now here you can see there are these commands are there. These options are there. This is known as the switches, like from and the rise, fall, through. What is a fall through the two? So what I'm going to do in a couple of slides, I'm going to explain you like, okay, what is the meaning of what is the terminology, and what are the different things, and then I'm going to help you in terms of the setup and a hold. What is the setup? What is the hold? And then we will come back here, and I will just correlate those things like, okay, here if it is written from, then what is the meaning of here as a from? So I will just swap it here and there. So any point of a time, if you will see there is any, if you are losing the way I'm explaining, if you're missing something, just ping me. Don't think like, okay. Uh, I think you can see my full screen slide. Am I right? Say yes or no. So it's a day 6 slide. Yes, sir. Okay, great. So now, before we will discuss, at least we should know the different terminology. So in analysis, if you remember the very first day also I have mentioned this particular part, like it's a tool can understand a particular language. And when I'm saying the particular language, right now the tool is able to understand our English language. It can read it now, but there are going to be certain keywords. So there is a certain way which a tool can understand. Like if I'm saying capture flip-flop. So what is the meaning of a capture flip-flop for the tool, and what is the meaning of uh, basically the launch flip-flop? What is the meaning of a 2 in the report check? If it is a -2, what is the meaning of that particular 2? You have to understand that thing. And you should also visualize like, okay, -2 minus from the circuit point of view, how it is from the circuit point of view, how the things are there. So just give me 1 second. Okay, so I'm back. Yeah. So now it's in this diagram. So if you can see, there are two flip-flops, and there is a FF1, FF2. Now there is a launch flip-flop and capture flip-flop. So you have to understand what is a launch flip-flop and what is a capture flip-flop. Before that, you should be able to understand which timing path you are going to do the analysis. So like my favorite example, like you have to travel from your home to your college. So when I when I just use this example from your home to your college, that means if I have in place of if I will just give you certain template, and if in that particular template, if I will ask you just to fulfill from, because we are going to do the analysis that the path between your college and your home, so that in which direction I want to do the analysis. So for from that point of view, you are traveling, that means your data is traveling from your home to your college. So that from is basically from where you are traveling. So this, in this particular case, if in this particular diagram, if you are saying like, okay, my data is traveling from FF1 to FF2, from FF1 to FF2. So this from is basically FF1. So in our report also, it is going to be as a from. So if we will say like, okay, I need a report from FF1. So it will give you the reports from FF1. Now in this diagram, it maybe it looks to you like, okay, it is a one path between FF1 to FF2. So then why there is a need of a from, or maybe we can just say from is should be good enough, because from is there, and there is no need of any two. Yes, you're right. If it is a single path, maybe you can say there is no need of a two. But let us suppose if there are three or the four flip-flop, maybe there is a FF3, FF4, FF5. And that means from FF1, there are the different ways. There are different, uh, basically the path. And they are ended up in a FF3, FF4, FF5. It's the same thing. You want to go from your home to the college or the airport, the bus station, or maybe some shopping mall. So if you want to do the timing analysis, you have to specify like, okay, I want to know how much time it will take for me to travel from my home to shopping mall. So similarly here also you have to tell the tool like, okay, I want to know, I want to do the timing analysis from my FF1, from the FF1, the path starting from FF1 to maybe some FF3 or FF4 or maybe the FF2. So that's the significance of from and the to in the reporting point of view, the timing reporting point of view. Now from the terminology point of view, when we are talking about the from, that means the data is launching from FF1. So it's basically the launch. So that's flip-flop is known as the launch flip-flop. And the other endpoint, that is other point where you're going to where you're going to basically the path is going to be end, that is known as a capture flip-flop. That means that particular flip-flop is going to capture this data. So now I'll just explain you three things. One is the from and the to, another is the launch flip-flop and the capture flip-flop, and the third one is a path. Now every path has a start point and an end point. So in this particular case, the end point is a FF2. So it is going to be end. So the analysis we are going to do, that, okay, this particular path is going to be end at D2 pin. So that means now we are talking about the end point. End point is this D2 pin. So after this, we are not going to do any analysis. So our goal is like, okay, your data should reach at a D2 pin. So that's going to be my endpoint. But now question come, what is the start point? The start point is a Q1 pin or start point is something else. Now this start point, if it is a Q1 pin, then the question come like, okay, from where this data will come at a Q1 pin, from where the data will come. You can say like, okay, data will come from the D1 pin. Now, if you're going to do the analysis, then either you can do the analysis from Q1 pin. You can say like, okay, there are going to be certain delay from D1 to Q1. But if you remember, in a flip-flop, when the data is going to be reached at a Q1, at what time data is going to be reached at a Q1, that depends on the clock. Basically, when this flip-flop is going to be triggered. So once this, let us suppose if this flip-flop is triggering today, then after some time you will get a data at Q1. But if this flip-flop is going to trigger tomorrow, then you will get the data after some time when the flip-flop is going to be triggered. So if you're going to do the analysis of this particular data, and if I will ask, okay, how much time it will take a data to reach from FF1 to FF2, then you're going to answer it like, okay, the data will reach from FF1 to FF2 after, maybe it will take maybe 5 seconds after this flip-flop is going to be triggered. So once the flip-flop is going to be triggered, then after that there is going to be the 5 nanosecond. So our start point, so for this particular activity, for this particular analysis, our start point is not a Q1, our start point becomes a CLK. That means the start point of this particular path is a CLK. That means first we are going to check it whether this CLK pin, whether this clock has reached here or not. And the moment it is going to reach, after that, the time taken by the data to reach as a D2 pin. So that's basically the start point, that's the end point. So again, so there are three things. Launch flip-flop, the flip-flop which is going to launch the data. Capture flip-flop, the flip-flop which is going to capture the data. That's the one thing. Second thing is your from where you're launching and to. It's like from and to. FF1 and FF2. From is FF1 and to is FF2 in this particular case. And the third thing is the start point. Start point is, this is the start and the end point combination. So start point is a CLK, because till the time this clock, this flip-flop is not going to trigger, there is no I would say, doesn't matter even if you will do certain analysis, because everything is with respect to, with reference to the CLK. So it's a CLK till this particular D2 point, that is going to be your start point, start point, end point. And if anyone is going to ask, like, okay, what is the path you are doing the analysis? So you have to say it is from FF1 CLK1 to FF2 D2 pin. That means you are going to tell it is a start to end. And everything I'm just telling you, everything, all these three things, a start point, end point, from, and the to, you will see tool understand this particular language, and the tool is going to give you the report in the same fashion. I will show you that particular part. Before that, someone is asking if more flip-flop than immediate flip-flop call. So, Rupesh, if I understood your question, first of all, your question is a little bit confusing, but I think your question is if there is a flip-flop after FF2, maybe FF3, FF4, FF5, and FF2 to FF3, there is a path, but there is no path directly from FF1 to FF3. Maybe you may be asking in that particular way, and then you are saying like, okay, the immediate flip-flop is going to be considered as a part of my analysis. Then the answer is yes. So we are going to do the analysis between register to register, and we are not going to skip the register. So the moment one register to another register, there is a path. We are going to do the analysis of this particular path first, and then from this particular path, from FF22, if there is a next flip-flop which is connected only with FF2, we are going to do the analysis between FF2 to FF3. But initially, when I was explaining from the parallel path. That means the path is starting from FF1 and ending at a FF2, FF3, FF4. It's basically in the same level. Basically, there is a FF3, FF4. I think, Rupesh, is it clear? I hope so, that he is clear with that particular part. Now, if it's clear, now let's see from the reporting point of view, if we are going to change certain reports here, like we did it in this particular way. Let me just do it again. Report checks. So let's little bit go up, and then you can see in this particular report, there is a start point. So you can see we are talking from the start point, end point, the same thing, the start point and the end point. And it was just talking about certain points. So this is basically the point. So they are talking about some 1491, 1645. So right now the naming conventions. So if you will just open your uh, Verilog file and if you will just check it, this is basically the flip-flop, the name of the flip-flop. Now in the report, if you want to see, you can see this is a 1491. Here also 1491. So the our analysis, the delay calculation, that started from 1491 CLK. That's the same thing which I showed you. Like in a register to register is going to be start from the CLK. Flip-flop CLK pin. So this is basically the name of the flip-flop 1491, and then this is the CLK pin. And then there is a Q pin, and then there may be certain inverters, all the inverters and all other cells are there. And then check the endpoints. What is the endpoint? So endpoint is 1645. Here, this is again 1645 and the D. It's the same thing. So whatever I have discussed is the same thing. Here you can see they were talking about certain library. In that particular library, this is a flip-flop, D flip-flop. And that is the CLK pin. This D flip-flop, this is a Q pin. Now here, this is a D flip-flop, it is a D pin. And if you will just go back and if you want to see the respective .lib file, then you will see all these details there. That means in that particular .lib, you can see the CLK, Q, D pin. Is it clear? Any question till now? Yes, no, clear. Please interact. That's the only way. You have to type it. You cannot skip it. Okay. Only 3-4 people they are saying is clear. So a good question. Vinay is asking, is this design having only 2 flip-flop? No. It is just right now it is just showing a report only for the one timing path. So in the report, what happened if I will tell you like there are thousands of paths, and if I will ask you like okay, do the report check and it will give you the result of all the paths, then it's going to be very difficult for you to analyze those paths. So what happened? There are different options, and what the tool is saying, I'm going to show you the result with respect to the critical path, the most critical path, or worst path. So yesterday someone asked, how can I figure out the critical path, the critical path of my design? So what is the critical path? The critical path is for a particular check. So if you are going to do the setup and a hold check, we will discuss what is the setup and hold check. So if you are going to do a certain check, for that particular check, it is a worst result. Worst result is coming. So that become your critical path. So it's going to give you the result of a most that particular critical path or the worst path, I would say. It is going, once you are going to fix this particular path, then the other path will come into the picture. And but there are options. You can print the multiple 2, 3, 4 paths at the same time. Where so there are using the reports, using a lot of options. You can do all those things. Yes, good question, Patil. If we will not provide the path, tool will automatically choose the critical path. But if you are going to specify a path, then tool is going to report you with respect to that particular path. So it's just like you are asking Alexa, like, oh, okay, Alexa, tell me if I will travel from my home, if I will start from my home, how much time I will take to reach my destination. And in your destination list, there are, let us suppose, there are 10 different uh, paths are there, 10 different destinations are there. Or then you are asking the Alexa, like, okay, tell me what is worst path, longest, basically the destination. So it will just tell you in that particular way. So the tool is programmed in that particular way. Like, okay, if you are not going to provide any particular path, it will tell you the worst one. And if you're going to provide to and a from in your report check, so it is going to give you the result as per that. Good. I think this point is clear. One more point. See here, it is talking about the rising edge. So you can see this is a flip-flop. They are talking about the rising edge triggered flip-flop clocked by CLK. That means this particular flip-flop is going to be triggered by the rising edge. So in this particular way, see, you don't, if I will say, I don't know my I don't know my circuit right now. In the sense, I haven't opened .v. I don't have any schematic in front of me. And now if you're going to do the analysis, how you're going to figure out that the flip-flop is going to be triggered on the positive edge or the negative edge? Or this flip-flop is basically the positive edge triggered, the negative edge triggered. So report, the way tool is working, report is the tool is going to tell you like, okay, this is a rising edge triggered flip-flop. And it's showing rising edge triggered flip-flop. And which clock is going to trigger? That is a CLK clock is going to trigger it. Then even our capture flip-flop. So this is basically the start point. There's a launch flip-flop. This is the capture flip-flop. And in the capture flip-flop is also the rise trigger flip-flop. So in this particular way, now we know like, okay, data is launching by a positive edge trigger flip-flop and captured by a positive edge trigger flip-flop. So that portion, that reports is also here. Now let's come back to our slide. So here I've showed you what is a capture, launch, flip-flop, data arrival path. Now let's talk about what is a data arrival path, and then there is another terminology which is a data required path. Before that, launch clock path. So this is a clock path. So that means the clock is going to travel through this particular path. So the clock path which is associated with the flip-flop FF1, and this FF1, if this FF1 is a launch flip-flop, then this path is known as a launch clock path. Now the path which is associated with the FF2, and this, if this FF2 is working as a capture flip-flop, then this path is known as a capture clock path. Now let us suppose you have another, let me just see. Yeah, so let us suppose you have another flip-flop here. Let me just change color. So let us suppose you have a flip-flop here. Okay, wait a minute. Now if you have a flip-flop here, come on. This is your flip-flop, this is your D3 pin, this is your Q3 pin. There is a path here. And then you have a clock, something like this. So in this particular case, what is happening? It is basically, there is a path, this, the complete path, you can say. Now in this particular path, this, if no, this is a clock path basically. But if I will talk about this particular path, so this is basically, let us suppose you want to do the analysis between FF2 and FF3. If you want to do the analysis between here. So in this example, FF2 to FF3, this is going to be my capture flip-flop and this is going to be my launch flip-flop. The moment it becomes your launch flip-flop, that means this particular path, this part, the green one, it become your launch clock flip-flop. Sorry, launch clock path. So initially, initially it was a Basically, initially, right now, it is a capture clock path because we are talking about the path between FF1 to FF2. Now, if you have another path here, somewhere here, say FF3, and you're going to do the analysis between FF2 and FF3, then this path is going to be converted into a launch clock path. Converted in the sense is just like for the tool understanding, now it is a launch clock path because from the FF2 now you're going to launch the data and you're going to capture data from FF3. Is it clear? Any question in this particular thing? Okay, someone have a lot of questions. Okay, I think I missed a lot of questions. So the question is what time in the second column indicates. So we will discuss the report in detail, Surya, don't worry. Can we combine slow and the fast sleep if we need to meet a timing constraint? So Prabhavati, yes. So for the fast and the slow leap, yes, you can do it, but it depends on the tool. It depends like what exactly you want to do. So you're saying if you don't, if you are not able to meet a timing constraint, can I combine this thing? So answer is no. So it's not like you have to meet your constraint, and that's the reason you are using the libraries. It's in a different ways. In all the libraries, you have to meet the constraint. Means in all the corners you have to meet the constraint. It's not like just to meet a particular constraint you will say like okay in one corner it is meeting, okay then done. In another corner some other constraint is meeting, is done. No, we are not going to do in that particular way. We are going to do in a different way. In all the corners all the constraints supposed to be met. Okay, so now the question is like if we are going to compute from FF1 to FF3 the data arrival path, do we need to include FF2 D to Q in the data arrival path? So Patil, basically uh, you're not going to do the analysis between FF1 to FF3 directly. You're going to do the analysis between FF1 to FF2, then FF2 to FF3. So that's the way we do it. Because FF2 is just like in a gate. First do the analysis between FF1 to FF2 and then FF2 to FF3. There is no point of doing a analysis directly between FF1 to FF3. I think you got my point. Okay, so question is why? So answer of your question is very simple. FF2 is going to trigger with the clock. And once it is going to trigger with the clock, then only it is going to launch the data. Now, in this particular scenario, you can say like, okay, the clocks are is going to trigger this particular the clock is also traveling from here and it is going to trigger this particular flip-flop anyhow. But that's not the case. So this is a we took an example of 10 nanoseconds. So this particular flip-flop is going to trigger at 0 nanosecond and it is going to trigger at 10 nanosecond because both are the positive S trigger. So it is a 0 nanosecond, 10 nanosecond, 20 nanosecond. Similarly, this is 0, 10 and 20. Like this, it is going to trigger. So even if from FF1 to FF2, if your data will reach within a 1 nanosecond, but you have to wait at this particular stage because that data reaches at a D2 pin, but it's not going to capture and travel to the and transfer to the next stage till the time this clock is not going to trigger. And this clock is going to, this flip-flop is going to trigger at a 10 nanosecond. So that means you have to wait till 10 nanosecond anyhow. So if you are going to do the analysis between FF1 to FF3 directly, then as per if I will see, you're going to do the analysis here. you will see, and you will say like, okay, my data will reach within a 1 nanosecond. And then after that, you have to just wait for another 9 nanosecond because this flip-flop is going to trigger at a 10 nanosecond. And then once this is going to trigger, then again you will just check it between FF2 and FF3, and you will say like, okay, now again it is a 1 nanosecond. So the point is, that's the way you have to do the analysis. That's the right way to do the analysis, and that's the reason I'm saying first you have to do the analysis between FF1 to FF2, and then FF2 to FF3. So Shravan, it's not about resetting the FF1, sorry, FF2. So resetting is a different thing. Resetting just reset the data. It's not going to reset the clock. Like, okay, the moment you are going to reset, it is going to trigger at that particular time. Triggering is based on the clock. It's not based on some reset pin. So even if you will reset it, what is going to be happen is you're not controlling the triggering of this particular flip-flop. Yes, if you will provide different clock for launching and the capturing, then will the path change? Yes, the analysis is going to change basically. Same, even if it is a asynchronous reset, it is a synchronous reset. Think from different angle. What the reset pin is going to do? Reset pin is not going to reset your clock. So you're not resetting the clock. You're resetting the data. So set and the reset is basically resetting the output data, your data. It's just like you are just press a reset button and everything is come back to the default value. Like in your mobile, there is a reset pin. You just press the reset, everything is going to reset and reaches to the initial value. And but that doesn't mean it's going to change your clock. I think I'm making sense. Can you share? Okay, I think okay, that's okay. Then, sir, what is the whole timing assist by the tool? Because I only see the setup time assist. We'll discuss that particular point. Kind request false path, multi-cycle path. Okay, meaning, purpose, launch, captures. Is it having delay from paths? Okay, so you want to ask everything right now? Okay. So data required path is equals to the clock period as per the diagram. Data required path is the clock period as per the. Okay, so those things we will discuss, don't worry. Okay, so I think now this terminology is okay. Now launch clock path, capture clock path is okay. Now let's talk about the data arrival path. Now data arrival path is a from this red line you can see from this particular clock source, then the launch clock path plus clock to Q, that delay, and then from Q1 to D2 pin, whatever is the delay. So if you are just going to sum up that particular delay, then you can say, okay, it's a data arrival delay. And that's the reason we are saying it's a data arrival path. The required is, okay, this is for the clock data required, and then there are certain setup and a check. So you can think from the arrival and the required in such a way, like, okay, if you have to catch a train, so for the you are basically or a plane, basically you are a data. So how much time you will take to reach at a airport or the railway station, that is basically your arrival time. Now when it comes to the plane or the train, that's something it's a required time. It's they will reach, they are not going to change their schedule as per you. They are going to change everything. They are going to do everything as a predefined. So the clock, everything is a predefined. So if you are going to, if this is a path, and as per this particular path, everything is predefined. Like, okay, after this much of time, you will your the clock will reach here, and then there are certain constant, and then it will say like, okay, it is a requirement. It is the requirement of the data that data should reach within this particular time, or it should not reach within this particular time. So that's become the requirement for the data. So from the data point of view, It's all about the requirement. The requirement is you should reach there, else you will miss the train. So that's the requirement. How much time the data will take or you will take to reach at your destination, that is your arrival thing. Like, okay, you're taking this much of time. So someone is asking like, okay, how can I say FF2 was launch, FF3 was capture, even though both have the same clock delay? So launching and the capturing is basically with respect to the data. So when the FF2 is going to launch from the Q2 pin, that means that become a launching flip-flop. And if some other flip-flop is going to capture the data, that become a capturing flip-flop. Same clock delay or the different clock delay, that is a different, that's a different, don't be confused with that. Okay, now let's discuss about the setup and setup and hold. So this is my circuit, boy, small circuit. I just took an example for your understanding. So FF1 is a launch, FF2 is capture. There is a certain combinational logic. Now, setup time is basically, from the definition point of view, it's like in your college. It's happen usually it happen like, okay, your class is going to be start at 9 a.m. Then you should be in the class 5 minutes before your uh, professor come. That's that's a requirement. But yes, I know most of the people don't follow that particular part. But yes, that's the requirement. Like, okay, you should be in the class 5 minutes before. Think the same thing in a different analogy, and that analogy is like if you have to catch a plane, then what is going to be happen? So in the airport, they said like, okay, if your boarding time is 10 o'clock, you should reach at the airport 45 minutes before the boarding time. So that's 45 minutes. Why there is a 45 minute before? Why they have this particular checklist? So that you can come and you so that they can assure you like, okay, if you will reach 45 minutes before the boarding time, you can catch a plane. There's no problem. So that means they are giving you a guarantee like, okay, if you will reach, if you can come 45 minutes before, 1 hour before, then there is a we are giving you the 100% surety like, okay, we will capture you and we can onboard you on the plane. Similarly here also in a setup time also, the flip-flop, the capture flip-flop is saying like, okay, if you want me to capture the data, if you want me to capture the data correctly, and if you want me to capture the data at a D2 pin and transfer to the Q2 pin, I have a very small request or I have a constraint like, okay, data should reach at a D2 pin certain time before the clock. So the clock is going to trigger at a CLK2, clock is going to be there at a CLK2 pin. Whether it is a rising or the falling edge, that depends on the type of triggering. But what FF2 is saying, if you want me to capture the data at D2 pin correctly and transfer it to the Q2 pin, if you want to do in that particular way, then if you want me to do in that particular way, so please make sure you should reach at D2 pin certain time before the clock. That's the setup time. So setup time is basically the requirement of a flip-flop, requirement for the data to be stable before the clock edge. That means the data should reach somewhere here before the clock edge. Or I can say in a different way also, Data launched by the launch flip-flop. Data launched by the launch flip-flop. This is launching the data. And then captured by the intended capture edge of flip-flop. So there is a concept of an intended capture edge. Now this intended capture edge in the sense clock is going to capture the data. So think in this way, why I have mentioned this intended capture edge. So if you remember, I mentioned like, okay, in a 10 nanosecond, this flip-flop is going to trigger at 0, is going to trigger at 10, is going to trigger at 20 nanosecond, 30 nanosecond. Now you're saying I'm launching data from here and it is going to take 12 nanosecond. But I want to capture this data at 10 nanosecond. Is it possible? No, it's not possible, because if you are launching the data from here and if it will take 12 nanosecond, so you are launching this at 0 nanosecond, this it will reach here within a 12 nanosecond. That means it will reach at a D2 pin at 12 nanosecond. But you are saying, no, I want to capture this data at 10 nanosecond. So your intended capture edge is 10 nanosecond. And if you are not able to capture the data at 10 nanosecond, there is a failure. But the moment I will change my intended edge, now if I will say my intended edge is at 20 nanosecond, then definitely we can capture this particular data. So now setup check is, what is the setup check? We were saying FF2 is requesting to us like, okay, if you want me to capture the data, data should reach certain time before the capture edge. Now which capture edge? 10 nanosecond or 20 nanosecond? Now if I will say 20 nanosecond, then there is no problem, because 20 nanosecond it is reaching 8 nanosecond before. But if we are talking about the 10 nanosecond, then there is a problem, because it is reaching after that particular clock edge. So that means intended capture edge. So FF2 is saying I can capture the data only when data will reach certain time before the clock edge. No problem. So now that is the independent, that is the signal, the statement passed by the FF2. Now if the data is launched at 0 nanosecond, then you decide as a designer what is the intended capture edge, and accordingly you can do the setup analysis. Now if you are going to do the setup analysis at 10 nanosecond, then there is a failure. If you want to do the setup analysis at 20 nanosecond, then there is no failure. It's the same thing if you are starting from your home at 10 o'clock, and if you want to catch a plane at 11 o'clock, you cannot do it, because 45 minutes you have to reach before, you have just a 15-minute of travel time. But if you want to catch a plane at a 12 o'clock, there is a possibility, because now for the travel time point of view, you have 1 hour 15 minutes. So if you want to do the setup analysis, if you want to do the analysis 15 minutes, there is a chance of failure. If it is a 1 hour 15 minutes, there is a chance of like, okay, it's going to pass in each and every case. So that's the way we do the setup analysis, and we figure out like, okay, whether it is a failing or it is passing. How we are going to check it? We are going to check it like, okay, launch flip-flop FF1 should arrive at a data input FF2 latest by capture edge minus setup time. So it's the same thing which I have just explained. The time it will reach and then the minus setup time. Now let's try to understand from some diagram point of view, from the waveform point of view. So this is my clock. Here I'm taking an example of 4 0 nanosecond, 4 nanosecond. Now this is your launch. That means here you are going to launch at 0 nanosecond. So this is your data. So I just took an example of 3 data, like, okay, 3 different time frame. Just an example, like, okay, let us suppose the blue, orange, and the red, and it is taking basically the data is taking these are basically the case 1, case 2, case 3. If data is going to take the blue one, then what is going to be happen? If it is going to take the other orange, then what is going to be happen? this is your clock which is going to reach here. Obviously 0 and a second, 0 and a second, both the clocks are same, no delay in the clock. So this is going to be triggered at 0, this is going to be triggered at 0, going to be triggered at 4, this is going to be triggered at 4. And you know, if you're going to launch at 0, you cannot capture at 0. You can catch on a next available edge. So next available edge is a 4 nanosecond. So that means you're going to launch the data at 0 nanosecond and you want to capture it at its 4 nanosecond. Now your intended edge is a 4 nanosecond. So two things, one is the available and the another is intended capture edge. Now here, if you are going to capture at 4 nanosecond, out of this, first you have to check it. Okay, 4 nanosecond, the clock is going to trigger. What is the setup time? So this is basically my setup time. So now I'm just saying like, okay, my setup time is a 0.3 nanosecond. So that means your data should reach at D2 pin 4 minus 0.3 nanosecond. That is a 3.7 nanosecond. So if my data will reach at a 3.7 nanosecond, then there is no problem. But if it is not going to reach before 3.7 nanosecond, there is a problem. So out of this, these three diagram, you can see the blue one, it is reaching before this blue line. So that means there is no problem if the data will reach somewhere here. But for other two, there is a problem. So there is a setup violation. So if you are going to calculate the setup violation, this is the way we are going to calculate the setup violation. Now the question comes from the reporting point of view, how the reports in the report, how you will get it. So in the report, what is going to be happen? It is going to calculate this 4 nanosecond, which is a time period. It's going to subtract the setup time, which is a 0.3. It become 3.7 nanosecond. Now this 3.7 nanosecond become your required time. Then you are going to calculate this arrival time. Now, if arrival time is less than the required time, then there is no violation. But if your arrival time is more than the required time, then there is a violation. So this less than, this greater than, we usually talk in terms of the slack, setup slack. So that's, I will show you in the report also. Now, you can say like, okay, you want to fix this particular part. What I did, I just added a 0.3 nanosecond delay. That means your clock is going to shift. Now this edge is going to be at a 4.3 nanosecond. This is at a 0.3 nanosecond. If you are going to subtract at 0.3, it becomes 4 nanosecond. Now this orange is clear, no problem in case of a orange. This is a slack which I was talking about, data required time minus data arrival time. Required time, now it is a 4.3 minus 0.3, it is a 4 nanosecond minus data arrival time. This is a data arrival time. Now if this is positive, that means the slack is positive, no violation. If slack is negative, then there is a violation. So we can do in that particular way. Now if you want to add more 0.3, let us suppose, then maybe you will just shift it like this, and then basically you can say like, okay, now in all the cases my slacks are positive. So this is setup in terms of when it is violating, when it is not violating, how you're going to calculate that particular part. Any question till now? Guys, yes, no, anything? No question? Anyone else? Okay, so now if everything is clear, now let's see in the report, same report, how things are going to, how you can see those report and how you can do the analysis. So report checks. So someone is asking, is there any method also to fix setup time violation? I think I already gave an idea, like okay, how to fix the setup violation. So the clock skew is good for the setup check. Yes, you can see, you can decide. So all such concepts, all such things, I think if you know the basic concept, then you can say yes or no. It's very easy for you. So now here, we were talking about certain delay. If you will see here, so this portion is clear to everyone. Now this is delay, this is time, this is description. Now let's try to understand a couple of things here. This is basically the clock rise. So basically we are talking about the clock source, like okay, how much is the clock source from the very start point. So that's the clock source. Then we are talking about the clock network delay. That means the delay in a clock path. That is a clock network delay we are talking about. Like okay, launched. So right now this section, the first section is basically. So if you will see in the report, there are three sections. The first section is a the topmost summary. This is known as a summary header section. The second section is a this particular section. Now in this section, it is if you will see here, it is written a data arrival time. That means now we are talking about data arrival. So this is the arrival section. And the third is basically the data required time. So if you will see here, it is a data required time. So the way I have done the calculation, like, okay, first I have to see like, okay, which particular path, then we are calculating the data arrival, then we are calculating the data required, and then we are going to do the mathematics. What is that mathematics? We are going to subtract it, the slack, we are going to calculate the slack. And in the setup slack, we are talking about required minus arrival. So if you will see here, they are doing the same thing, required and then the arrival. They are talking required minus arrival. And if whatever the value is coming, it is a 6.42. If it is positive, then they will say it is meeting. That means there is no violation. But if it is not meeting, it will say like, okay, there is a violation. Now, some people are asking question, play a major role in a setup check or setup queue or the slack. What play a major role? So slack is basically the mathematics. It's just like some numbers, subtraction. Okay, queue is it's a completely different thing. That is basically in terms of the clock skew, not the setup skew. Don't be confused with the setup skew. Just it's a clock skew, and the slack is basically the setup slack. Slack and setup slack is basically the subtraction. It's just like required minus arrival. Okay, then some okay, everything is related to academic side. Okay. Now here, I think now you are clear from the reporting point of view. Like okay, there are 2 or 3 different reporting thing. I just gave you an idea. Now let's see in a arrival section what happened. So it is a clock network delay we have just discussed. Now after that, this is a clock pin like okay from here to Q. What is the delay? So this is that particular delay. If you will see here, we are talking about this delay. So the way we read it, it is like clock and then the Q. So clock pin to Q pin, what is the delay? That is this particular delay. From this Q to the something as a Y, what is the delay? This is my delay. In this particular way, everything is there. And at the end, you have reached at this particular D point, and this is basically 3.52. That is the data arrival time. So the total data arrival time is this. Now internally, this particular portion, someone is asking about the third column, this V, what is this V and all those things. We will discuss that particular point. But right now, for you, just understand if it's basically not the V. It's basically, if you will see, it is this a symbol. If it is going in upward or in the lower side. Upward means there is we are talking about the rising edge. Lower means we are talking about the falling edge. So if you will see, this is a positive trigger flip-flop. So that means the clock is going to be the rising one. So it is basically the rising one we are talking about. As the output of the Q, the waveform which we are talking about, the signal, what is the nature of that particular signal at a Q pin? It is a rising or it's a falling. So if you remember when we have discussed the delay, we have discussed about this particular part, like, okay, we are going to do the both type of analysis for the rising also, for the falling also. So right now it is basically the rising thing. So at a Q, it is a rising. And then if it is at a Q, if it is a rising, then you know after the inverter, it's going to be fall. Then if it is a OR gate, then it is going to be the same state, the fall only. If it is again an inverter, then it's going to be rise. If it is a AOI cell, then it is going to be basically invert. So what if it is a rising, is going to be falling. Then again it is falling, then falling, falling. Then again there is a some gate, and that particular one is again a falling. After this there is a gate, it is basically the rising. So now here, if it is a falling, here if it is rising, then you have to just check it like, okay, what exactly this particular gate is. And that's the reason I have asked you like, okay, just go and just check the library and see what is the function of this A2BB to O. If you will ask me, it's very difficult for me just to figure out by the nomenclature like, okay, what is the function of this particular gate, but maybe it is basically the inverting the waveform. Then after that, there is a inverter. Then it is going to be inverted one. Then there is a AND gate, same OAI inverted. Then so in this particular way, we are doing this particular whole analysis, and we are calculating the total data arrival time. Now you can ask me like, okay, what is going to be happen if I'm going to do the analysis at a Q for the falling edge? Yes, you can do the analysis for the falling edge, and you can do in the sense the tool already did it. So tool did both the analysis for the rising edge also, for the falling edge also, both type of analysis tool did it. And after that particular analysis, whatever be the worst one or the best one, it is going to choose, it is going to calculate that particular result, and then it will tell you the result accordingly. So we will discuss like, okay, which one tool is going to pick as a worst, which one tool is going to pick as a best one. Come back. So this is basically the data arrival time. Now let's see what is there in the data required time. So this is my clock time period 10 nanosecond, and this is the 10 nanoseconds, the same which I have defined in the starting itself. You remember in our script, it was written create clock name clock period 10. So now if in place of this 10, if I will just put it as a 4, if I will put it as a 4 or maybe the 5, the things are going to change. So I will show you just after this. I will show you by changing it to 5, and then we will see whether we will get the same result or not. Obviously, we will not get the same result. We will get some other result. So I will just show you like, okay, this clock, how it is going to change. And it is the same thing, like whatever is written here is going to be the same thing here. Now, after that, this is a clock network delay. This is basically the clock network delay from the clock part delay. Then CRP, I think you just skip this particular part right now. We will discuss this thing later on. Then we are talking about like, okay, at a D pin of a capture flip flop, what is the, sorry, CLK pin, what is the time? So at a 10 nanosecond, this clock is reaching. So now the capture flip-flop is going to be triggered at 10 nanosecond. Then the next is a setup time. And this setup time was 0.07. So you're going to subtract. That's the reason as per the definition also. Your data should reach certain time before the clock edge. So the clock edge is this, before that is a 0.07. Then what is the required time? Is a 9.93. So this is your 9.93 is the required time. So data arrival time was a 3.52 and the data required time is a 9.93. Even if you will subtract, this is a 6.42. That means your slack is positive. That means there is no setup violation. Is it clear? Now I want all of you to tell me, is it clear or not? And if you have a tool loaded, just run this particular report once again. Okay, do one thing. I'm not going to do a lot of things now. You do it. Change this create clock at a in place of a 10, just make it 5. And just tell me what is your slack number. Same, everything is same. Those who already have this OpenSC installed, they did all these things. Make a change here. Period, make it 4 or 5. Okay, let's do it for the 5. If it is 5, tell me what is the slack. Just do this particular setup. Tell me. I'm just waiting. Take 2 minutes and tell me. So someone is saying 1.42. Okay, no problem. Let's see. Let's wait for other to answer. Okay. I always so do one thing. It's basically Jagdish is with respect to 5. Clock time period is 5, and then you're doing this calculation. Am I right? Everyone, do the calculation with respect to the clock time period 5. And then I will also do, and then we'll see whether it is matching with your answer or not. Just take a 2 minute to do this. Good. So most of you were able to answer 1.42. It's the same 1.42. Now let's try this particular command. So now report checks minus path type and just write min. Just try this one. Tell me what is your answer? What is the slack? Sorry. Let me just check it. What is this command? Help report checks. It's basically, sorry, it's the path delay. Okay, not the path type. So what do you have to do? Report checks minus path delay. Now just make it as a min and just enter and just tell me what is the slack you're getting right now. Okay, so slack is around 1.25. What is this around 1.25? It should be 1.25. It should be less than 1.25. Just give me the absolute number. There is nothing like an around. It's a mathematics. Simple mathematics. I'm not interested in an approximate value. Okay, so this is 1.42. Okay, that is the previous one. If you are going to do the min, then it is a 0.44, 0.44. Okay, great. What about others? Are you getting the same answer? Now, those who have done this calculation for the min, just see what is the difference. In this report, 0.44, if this is a slack, versus when the slack was 1.42. What is the difference in the report? I just want you to analyze both the reports and just try to understand the difference. So there are only few people, they are saying it is a 0.44. What about other people? Come on, guys, please. So someone just mentioned in a case of a path delay min, we are getting the best case report. So Patel, I'm not asking it's the best case report or the worst case report. You have to just tell me what is the differences. Just check both the reports and just tell me what is the differences. Highlight those differences. You know, in a school days, we did a lot of experiment and a lot of quizzes basically. 5 different things in these two picture. Then you have to tell me from that particular angle what are the 5 differences you can see in both the reports. So what is the difference if you are going to do the report checks versus report check minus path delay min? Let's take 2 minutes of time. I want everyone to do these two exercises and just answer it here. The first thing is you have to report what is going to happen if it is a report minus check minus path delay min. So we just discussed 3 things. One, what if the clock is a 5? Second, if you are going to mention this min. And the third, what is the difference when you are just doing the report checks by default and if you are going to do the report check minus path delay as a min. Tell me all these 3 things. I'm just waiting. What happened, guys? No one? Are you guys doing any hands-on in parallel, or only few people, like 2 or 3 people, they are doing this thing? So if you will see, there are two things. First of all, if you're going to change your clock, then you will get a slack of 1.42. That's, I think everyone answered it. With respect to the minimum, this is the answer 0.44. We have received this particular part also. So Surya, you are not able to install OpenSTA, but what about others? How many participants are here? I think there are almost like 300 participants. I'm just getting answer from couple of people. That's all. Okay, so this was the second one. Now I have asked the third question, like, okay, what is the difference between both the reports when you're going to do the path min? Now, if you will see, just compare with the section by section. Start point and the end point. The start point is 1499 and the end is also 1499. Let's see here. 1491, 1645. That means in this particular case, start point, end point, in both the case, if you see start point, end point, both are different. Here, that means the flip-flop combination itself is different. Here it is 1499, 1499. Here it is 1491, 1645. So now the question for you, here it is very easy for you to understand. 1491 and 1645, these are the two different flip-flop. In this particular case, it is a start and the rise, both are on the same flip-flop. Because if you will see the name, both are the same name. So my question is, how come? Can any one of you answer in the path delay min? How come start point and the end point? That means the launch flip-flop and the capture flip-flop both are same. So here, if you will see start and the end, that means the capture and the launch flip-flop both are same. Can you tell me any circuit where you have a path, timing path, and your start point and end point both are same? How can it possible? Any answer? Let me just check how good is your digital electronics. There is a circuit and your start point and a end point both are same. What kind of that circuit it is? That means your launch flip-flop and the capture flip-flop are same. What kind of that circuit it is? So Surya has a single flip-flop, but in a single flip-flop, how can the start and the end can be same? The capture and the launch. T flip-flop with a D flip-flop. What is this? T flip-flop with a D flip-flop. I think if anyone is going to ask you this type of question, the best answer is the answer given by. So Surya, 1-bit register is okay, but how come start and the end, right? Basically, the launching and the capturing flip-flop is same. Output of the flip-flop is connected to the clock of the same flip-flop. No, it's not the clock of the same flip-flop. It is a latch. How come? Come on, guys. It is a divided clock cycle. Uh, F/2 circuit, counter, toggle flip-flop, Q connected to D. Okay. So Q connected to D or the D connected to Q, both are different thing. But I can see, oh, few people are making good guess, and so few of you have answered correctly. It is a feedback path. It's a feedback path. Now, after that feedback path, now if you are saying, okay, so someone say Q bar connected to D. Come on. Now we are not talking about the Q bar or the Q right now. It's basically a feedback path. Now, what is that feedback path? Now let's try to understand what just happened here. It is basically there is a flip-flop. This is your Q. This is your D. Now this is your path. Basically, if any data is launching from Q, that is basically this flip-flop is going to be considered as a launch flip-flop. Now, if I'm saying it is a feedback path like this. So that means if I'm going to do the analysis, of this path, in this particular case, this flip-flop is launching the data from Q, and this flip-flop is going to capture the data at D. So this is the path I'm doing a analysis. Now, when it comes to the CLK, so you may be thinking like, okay, what is going to be happening with the CLK? Yes, so CLK is basically like this. It is CLK. So that means once at a 0, so if this is your clock, and in this particular clock, if you are launching the data at 0 nanosecond, so if you are launching it at 0 nanosecond, you have to see clock to Q delay, then you have to figure out this particular part. Now this data, this blue data will reach at a D after some time. And that means this flip-flop now going to capture this particular data, and this flip-flop is going to capture the data at this one. Now what is this? As per our clock, this is a 5 nanosecond. That means you're launching the data at 0 nanosecond. It is traveling like this, and it is coming at a 5 nanosecond. So if you will see in this particular report, it is launching the data at 0 nanosecond. So we are launching the data at 0 nanosecond. See, then there is a Q. Then there is a something as a X. Some circuit is there. Some circuit is there. So that means somewhere here there is a combinational logic. It's okay. So that means from Q it is passing through some combinational logic. Some output is coming, and that output is again connected with the D of the same flip-flop. The D of the same flip-flop. Now we don't know. We don't know this thing, whether it is a T flip-flop implemented using a D flip-flop, or someone was saying it is a some divided by F. Someone was saying some other thing. So why to make those assumption until unless you will not see the circuit completely? My question was not what is this particular circuit. My question was like, in which particular case you will have the same flip-flop as a launch and the capture both. Now here you can see again, it is capturing the flip-flop. It is capturing the thing in the same flip-flop at same particular place. But now if I want to capture this data at a 5 nanosecond, so somewhere here 5 nanosecond supposed to become, but here we are doing the hold analysis. So we haven't discussed about the hold till now, but yes, we are doing the hold analysis. And a hold analysis, we do the analysis on the same edge. So that's the reason you cannot see it here. So that's the reason it is saying like, okay, 0.03. It is just talking about that particular hold right now. So when I was talking about in terms of differences, this is basically the differences we are talking about right now. Okay, so now come back. And let me see if any one of you have any question. Okay, somehow my something is hanged in between. Am I audible to you guys? Okay, I can't see.
Hello.
Hello,
Puneet
ma'am.
sir, you're audible.
But somehow my screen is like I'm not able to do anything on this thing. It's hanged. I can't see this WebEx window. Yeah, now it is back. Okay, thank you, ma'am.
Thank you.
Okay, so now let me see if anyone have any questions. So people are asking about feedback circuit, data holding transmission lines. They are talking about calculating next stage of the state machine. We need to look at the present state. Okay, so now you're making things very complex. The moment you enter into the state machine, don't do that particular part. Make it as simple as possible. There is no memory in your circuit. How it is a sequential circuit, sir? So come on. So what do you mean by the memory in my circuit? Which circuit? The sequential circuit, the flip-flop is a part of a sequential. Am I right? Okay, I think so. You you may be confused. Sequential circuit, sequential element, flip-flop. That's a sequential element. Am I right? Okay, great. So that's one comparison I just want to show. So you can see the start point, end points are different. You can see here we are talking about some hold time. Here we are talking about, if you will see here, we are talking about some library time. So that means the time which we are talking about, that is different. Third difference was in terms of the clock. Here we are talking about the 5. That means we are talking about the after the uh, one cycle we are doing the analysis. But here in the minimum we are doing the analysis in the same cycle. That means not the same cycle, in the same edge. We are doing the analysis in the same edge. So now that's a third difference. So I think that's the main three differences. And apart from that, if you will say like, okay, here it is rising, 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 I think that's not the difference because the path is different, the combinational logic is different. So this rising and the falling, it has a dependency over the type of the circuit, the type of the path we have. Is it clear now? The differences in the two reports, if you are going to do the minimum, then what is going to be happen? The reports are going to change. If you are going to do the maximum, then the reports are going to change. So Tanisha, you're saying like, okay, if the slack is negative, then it's a case of a setup violation. Yes. It's a basically the violation, depending upon whether it's a setup or the hold, which type of analysis you're doing. If the same flip-flop is both capture and the launch, there might be a hold time violation if the path delay is less than the. I think the statement which you are making that's can be true. Yes. So I'm not going to discuss that particular part. If your analysis is good, you're making the right statement. If you understand, like, okay, what is the concept? Now, I can help you to understand the hold time also. But before that, I just want to show you couple of more options which I want you to try today after this class. So it's basically the report. This is help report checks. Now, if you will see this path delay. So there is a min rise, min fall, max rise, max fall, and min max. Only this particular portion. I want all of you to try once today. Once you will install it, once you will do this exercise, just try this thing. Analyze the report, understand the report, okay? And just check it in terms of uh, what differences are there. If you are talking about the min and the min rise, then what is going to be happen? If it is a min min rise, min fall, how things are going to change. So you have to do these type of analysis. And then if you are seeing like, okay, your reports are changing a lot, like, okay, your start point and end points are changing a lot. Like in this particular report, and it's very difficult for you just to come up with a certain analysis, like, okay, what is happening. Then you should try these two options, from, and there is a one more, to. Just try these two options, from and to. So that means use the same, from, same, to, and then do this particular analysis. So how you're going to do it? Report checks minus from. So let us suppose if I will take a underscore 1491. So it is underscore 1491 underscore, then minus 2. Then you can say in a 2 is underscore 1645, 1645, 1645. Okay. And then you want to do certain path delay minus path delay. And then if you want to see min, let us suppose the rise. So you can just use the combination like this and you can enter it now. Now you can see we were talking about the same input and output. That means the same input output will come. We did the minimum. That means path delay is minimum. And now we did something min rise. Then what is going to be happen? Min fall. What is going to be happen? I think that's something I will leave it to you. If you will do it, then you will figure out like, okay, what is going to be happen. Okay. So that's one sort of homework. I will request all of you just to try this particular part at your home. Now let's discuss one more slide here, which is a hold check. Now, setup, everyone is clear. Setup is like, if you want to reach the airport, you want to reach it certain time before your boarding time. Just to understand the whole time, you have to think in a different way. So you have a flight at 10 o'clock. You reach early. You're about to board your plane. Then what happened? Some other person came suddenly. Someone else, maybe your friend or maybe someone else, just came suddenly, and he or she was saying like, okay, I'm ready to give you double the price of your ticket, and but I want to board this particular plane. That's the one way. Or maybe that person will say like, okay, I have a more power than you. Like maybe I have a power in terms of my chacha is basically a politician or something like that. So then what is going to be happen for you? You have to skip. Maybe you have to skip for that particular plane. You have to miss that particular flight. So think from the flight point of view, think from the capture flip-flop point of view. The capture flip-flop, they don't know. Anything can happen at even the last moment. So they can not assure you like, okay, we will board you. You will be the part of our this particular journey, and now we can just uh, give you the guarantee like, okay, you can travel with us, because anything can happen at the last moment. So then they came up with a different check and they said like, okay, how come this other person reach at this particular time? So they will make sure like, oh, the second person means another person should not reach at the airport before we board the plane. Or you can say the second person should reach at the airport once you just board the plane, or you can say you just fly in the sky. So flip-flop said like, okay, My boarding time is 10. By 10:10, we will be in the air. So any second person, they should not reach. They should not reach before 10:10. Because if they will reach before 10:10, there is a possibility like they can use their power, they can use power of money or power of anything, and they can replace our passenger. So in case of a circuit, it is a responsibility of FF2. So FF2 is saying I can capture the data. So in the previous example, if you will see, this FF2 is saying I can capture the data launched from FF1 if you will reach certain time before the clock. Then I can give you the guarantee. I will capture you and I will just deliver you at a Q2. I can give you the guarantee. And that's the reason we were talking about the setup, like, okay, certain time before the clock, I will reach here. So if my boarding time is 10, I will reach at a 9:15. Then they come up with a second check. In the second check, they said like the other data. Now in this particular case, the other data. So this flip-flop is going to launch a data at 0 nanosecond. And this flip-flop is going to launch the second data at a 4 nanosecond here. So first data it is launching at 0 nanosecond. The second data is launching at a 4 nanosecond. Now, so the way they are doing the check, they are saying if second data, that means the 4 nanosecond data, it should not reach certain time, or you can say in a different way, it should reach certain time after the clock edge. Same thing, like in the case of a plane, I just gave you an example. The second person should reach after certain time of the boarding of the plane. That means the boarding time is at 10. Within the 10 minutes, we will be in the air. So that means the second person should reach after 10:10. Or you can say the second person should reach 10 minutes after the boarding time. Because if it will reach after the boarding time, it is not going to disturb the passenger. Same is going to be happen in this particular circuit. If the second data, that means the second data is a 4 nanosecond. If that 4 nanosecond data, the data launch at a 4 nanosecond, it should reach after certain time of the clock edge. So the clock edge is this clock edge, and this clock edge is basically this 4 nanosecond clock here. Now it is shifted at 4.6. That means this 4.6 clock edge, the clock edge at 4.6 nanosecond, this edge supposed to capture the data launched by 0 nanosecond. So for this particular data, for this 4 nanosecond, this data should reach certain time after the 4.6 nanosecond. And that time after this 4 nanosecond, whatever the time, that is known as a hold time. That means we have to hold this particular data for this particular time, or we can say like, okay, this data should not reach before this particular time. So that's the whole time. So now here you can see we are talking about the same edge, 4 nanosecond and 4.6 nanosecond. So this is the same edge which was like uh, in this particular case we have added this 0.3 times, but if you will see this 4 edge and this 4.6 edge, 4.6 nanosecond, both are the same edge as such. So from the source clock source point of view, it's the same edge. So that means this data, the data launched at a 4 nanosecond, should reach the capture flip-flop after certain time of this edge, which is a 4.6 nanosecond in this particular case. So now if I will talk about, so how it is going to be possible. So in a case of a circuit, I will say waveform, this is my clock, this is my delay, that is like from clock to Q delay, this 4 nanosecond. Now this is the clock, and capture clock is going to be somewhere here only. So that is my capture clock after a 0.3 nanosecond. So this edge shifted by 0.3 nanosecond, it is this particular thing. Now my data, this particular data should reach after certain time of 0.3 nanosecond. So there is going to be hold time, and data should reach after this. Now if the data is reaching before this, like in this particular case, it is reaching here because from Q1 to D2 we are considering like okay, pure ideal scenario. So that means there is a there is basically a violation. Now, if it is going to, if you will just add a buffer here or something here, then what is going to be happen? This D2 at a D2 data is going to be 0.4 plus that delay of this particular part. So this waveform is going to be shift in a right hand side, and then you can fix the hold violation. So here in this particular case, there is a hold violation. And if you want to calculate these hold slack, how you're going to calculate? You're going to calculate the required time. You're going to calculate the arrival time. And if your arrival time is greater than the required time, arrival time is greater than the required time, then there is no problem. That means there is no violation. So now we have discussed the two type of violation. One is the setup, another is a hold violation. Now the setup, data should reach certain time before the clock edge so that the capture flip-flop can capture the data correctly. Hold time is the second data should not reach certain should reach second data should reach certain time after the clock edge. That's a hold check. So I just gave you the example. So hold, maybe it's a little bit confusing for you, but just try to understand the analogy which I gave you. Just work on that particular analogy and just try to understand, like, okay, what exactly hold check I'm talking about. Because if these two checks are meeting, the setup is also meeting and the hold is also meeting, that in that particular case, the capture flip-flop is giving you the guarantee, like, okay, I can shift your data correctly 100% from deep into Q pin. Okay, so any question? Clock convergence, we will discuss that thing later on. Right now, any question in the setup and a hold? So we are almost done. So this is a calculation which we have already discussed. So I will share these slides with you. You can check this particular part, and if it's required, then we can discuss tomorrow. So I just capture these equations. Okay, so now it's the time for question. Once explain hold in brief. So Mithul, I will request you, because even if I will explain once again, it's not going to help a lot. I request you just listen the video once again. I think it's already live on YouTube. You can just go back, listen that particular part, just see if you understood. And if you are not able to, if still you have a doubt, then tomorrow definitely I'm again going to discuss both the definition once again. So I just want to give you some time to digest this whole part. Tomorrow I'm going to give you the explain you once again. Okay. Okay, so I think someone is asking about what is this 5.6 shared for yesterday and today is the drive same. What is that? Is the STF 5.6 shared for yesterday? I don't know what is that. That means yesterday we shared, I think, 4 and 5. Today is a 6. So today's slides I'm going to share just after our session. Okay. Yeah, so I will share the today's slide after this session. Any question, guys? If it is clear, just tell me yes, clear. If you have a doubt, just tell me there is a doubt. Okay, I think people are good. Okay, great. I think we are done for today. So, Firoza ma'am, I think we can close this today's session. I will share with you this slide and you can upload this thing on the drive.
Okay, thank you all. Thank you, sir. Thank you for your wonderful presentation on day 6 of the program. So Dear participants, there is one announcement from our end. All the participants who have any queries regarding their name correction or name not included in the attendance sheet, we request you all to please mail us to your coordinators under which you have done the registration. Okay, the details of the coordinators and their contact number and email ID is all present in the common brochure which is shared in the Google Drive, and also it is in the website. So we request you to please go through the website. All the mail ID and number is there of all the coordinators. So please make sure that the communication happens through the coordinator itself. So that would be great. So email ID is already mentioned in the chat box. It is eictiitg.nkn@gmail.com. So we request you all to please let us know through a mail. Then it will be very easy for us to track. Second thing is that we request all the participants to please attend the program from the registered mail IDs, or else it will be very difficult for us to track your attendance. And last, we would like to request all the participants to please go through the important announcement page, which is already uploaded in the drive. All the information regarding the program and all the important communication has been provided in that Google Doc page. So with this, we come to an end to day 6 of this program. So tomorrow we will join from the same link, okay, at 9:30 sharp. Thank you all. So we request all the participants to please get disconnected. The event will be closed in another 5 minutes. Thank you all. Thank you, Puneet sir. So we request you to please get disconnected.
Thank you, ma'am.
Thank you, sir. Thank you.